In this video I will show you how to read a vernier caliper in imperial units of measurement, that is in inches. And I will demonstrate it by using this ball bearing that I found in a dumpster after an elevator was removed from the elevator shaft. Okay, so first off, parts of the caliper. These are the jaws on the caliper, and these are spurs on the caliper. The jaws on the caliper measure outside diameter. The spurs in the caliper measure inside diameter. And there is one more thing. At the end of the caliper here, on the back side, there is a sliding metal rod. Just give me a sec there. There you can see it's very simple. That sliding metal rod comes out at the end of the caliper, so you can measure depth with it like so. You kind of get the idea there. You can measure depth with it, or like on objects like this. Okay, you get the idea. That's what you can do with a caliper. And this one is a 6-inch caliper because it says inches on it right about there. It also measures in millimeters and centimeters, but this is a 6-inch caliper or a 15 centimeter caliper. We are going to be using the inch scale and fractions of an inch on it, so don't worry about millimeters. Now, this caliper measures in inches, in whole inches, and in 1/128th of an inch. That's the finest amount of measurement on it. On the caliper you have a thumb screw here on top, which helps you look a measurement after an item is measured. There you can look the thumb screw, remove the item without prying the jaws like that, because that's just going to change your measurement. So you lock the thumb screw and then you can take a measurement. There is supposed to be a gap here between the jaws to clear some surface unevenness around the ends of the object, and this portion here at the bottom is designed to measure, let me just get a better contrast there, to measure threaded objects, thereabouts. Okay, so those are the parts of the caliper. Let's do some math. On the just a sec. On the main scale, caliper has two scales. A main scale. On the main scale, you can see numbers from here is 0 inches, and here is 1 inch, and then there is 2 inches there. Okay, we're going to be using the inch scale. And on the moving scale on the caliper, you can see a bunch of lines, 8 pieces of lines, and the digits 0, 4, and 8. Here is 0, 4, and 8, and the smallest division on the caliper is 1/128th of an inch. First, before you measure anything, you make sure that the jaws are closed, and in this position the two zeros should line up. Which two? The 0 on the sliding scale and its hairline should line up with the 0 on the main scale and its hairline. There are 3 adjustment screws, these 3 black screws, that one, and the third one down the road, that you can loosen, and make sure that the 0, when the jaws are closed, the zeros must line up. The way the caliper works is that none of the other hairlines should line up on a caliper, namely, let's just get closer, Namely, that hairline shouldn't line up on the that hairline on the sliding scale shouldn't line up with anything on the main scale when the jaws are fully closed. Neither should that, or that, or that, or that, or that, or that. But that one should and must, and it will. If these two zeros are lined up, then that 8 at the end, where is it? That 8 at the end must line up with one of the hairlines on the main scale. Okay, so the 8 on the sliding scale should line up with the one of the hairlines on the main scale. Any, because depending on manufacturer, this could vary. In this instant, it lines up with 7/8. Sorry, it lines up with 15/16. Now, on the main scale, you don't have any other number, just the whole inches. So every hairline is 1/16 of an inch, 1/16, 1/8, 3/16, 1/4. Sorry, 5/16, 3/8, 7/16, half an inch, 9/16, 5/8, 11/16, 3/4 of an inch, 13/16, 7/8, 15/16, 1 inch. You gotta know your fractions, and to read the caliper in inches, you have to be able to add and subtract fractions with common denominators and everything. Okay, you must have that skill, adding fractions, not subtracting, only adding for now, and finding the common denominator. Okay, let's take a measurement. First one, let's measure outside diameter on this bearing. I'll just zoom out a little bit, bear with me, wait for the machine, just a little bit. You measure outside diameter, like so. You clamp the object, make sure that it's parallel and everything, and you tighten the thumb screw, and then carefully take the item out, and let's take a measurement. For that, I'm gonna zoom in, just bear with me, and thereabouts. This is how we roll. First off, we are gonna need a whole number for the whole number of inches. Sorry, and this comes off the main scale. You have to take a look at the 0 on the sliding scale and determine how many whole inches has it passed. It passed 3 whole inches, so you write down 3. That's your, it's not your ones digits, it's going to be a mixed number that we're going to write down, okay? So that's the first number that gets written down. Then you count the 16th, first and second, 2/16. Okay, I know it's an 1/8 of an inch, don't worry about it. You can write down either 1/8, I'm going to write 2/16. Once you have 2/16 written down, what it represents is that the 0 on the sliding scale slid behind, or not behind, past 3 1/8 of an inch. So the measurement, the outside diameter of the bearing is more than 3 1/8, but a little less than 3 3/16. Okay, there's got to be a measurement between these two lines. So you write down that, because we always round down. To determine how many 128 are the measurement, is this measurement over 3 1/8 of an inch, we have to find an alignment. We have to look at the hairlines on the sliding scale and see which one of these hairlines line up with any of the lines on the main scale. So that one doesn't line up with anything, neither does that. That one is getting kind of closer to alignment. That's pretty good looking, and that's what is off again. Now it's the opposite way. This one is off that way, and this one is off this way. So I'm going to pick that one. The number that lives here is 3. If this one is 4, so if this one is 0 and that one is 4, this is 3. 3 what? These are 128ths of an inch. So that's 3 128ths. Okay, now we're going to make a measurement. We have 3 1/8 here. And now we have to add 3 128ths to it. You can see right away, this is where problems arise, where you need to add fractions. You've got to have this skill. So 2/16ths of an inch is how many 128ths? Well, in 1/16th of an inch, where do I write it? 1/16th of an inch is the same as 2/32 of an inch, is the same as, let me just, is the same as you can see where it's going. The denominator doubles, so must the numerator. So 1, 2, that's 4, that's 8. Okay. Every 1/16th of an inch is the same as 8 128ths. So out of this 2/16th, we have to make 128ths so that this fraction and that fraction have both the same denominators. So 2/16ths will equal 16. I'm just going to write it a little bigger, just a little bigger. That was 2/16. So that 2/16 is 16 128ths. Why is it 16? Because 1/16 is 8 128ths, so 2/16 will be 16 128ths. Okay, that's why I wrote this first fraction here in 16th, even though this is 3 1/8. 1/8, don't worry about it. You need to count the 16ths, that's probably the easiest. And after that, we had 3 128ths measured. Here, first, second, third, that's where the alignment is. So you have to add 16 128ths plus 3 128ths. And that's going to be, when you add these two fellows together, that's going to be 19 128ths. So the final answer is 3 inches, because don't forget the 3 inches. The final answer is, after this math is done here, 3 and 19 128ths. That's the outside diameter of this ball bearing. Let's take a measurement for the inside diameter, and sorry, other way around, and see how that goes. For the inside diameter, we are gonna need to use the spurs on this caliper, something like that. You kind of move it around to find the self-center and find the middle or the widest point on the inside, thereabouts. Carefully take it out. There we go. Okay, let's see what we've got here. There. I'm just gonna get rid of the first measurement. There, and wait for the camera to focus. Thereabouts. Okay, let's write down the first number, which is, sorry guys, which first number is red on the main scale. You have to see how many full inches has the zero, the hair with its hairline, how many whole inches has it passed. There is the 2 full inches on the, as indicated on the main scale, and the 0 is not past it because we're going from this way. The numbers go up that way. Therefore, we write down, where do I write it? I write it here, one full inch, and it looks like somewhere around 15/16, but maybe a little more. Let's see how much more. So I write down 15/16, and let's zoom in there for a little object lesson there. Okay, that's about pretty good resolution there, but I just want a touch closer. Just bear with me. Okay, so this is the sliding scale. Sorry guys, I hit that wheel every time. Just about. This is 15/16 here, and this is 2 inches. Okay, you can see that the 0 is past the 15/16 hairline here. However, if I look at the number of 128, this would be 1/128 of an inch. That's misaligned. So are the rest of the hairlines. This is the closest alignment, but you can see that just by the shoulder of a line there, they are not perfectly aligned. We have reached the measuring capability of the this sliding vernier caliper here. You cannot make a finer, you cannot take a finer reading on this one. We're gonna go with 15/16 of an inch there, 1 inch and 15/16, even though you can clearly see that the actual measurement is a little more than that, but it's so microscopic amount that now we're really talking about splitting hairs. But for accuracy's sake, you can see that it's not 128, but you can also see that it doesn't line up. So when I zoom out, thereabout, you can see that none of the lines on the sliding, none of the hairlines on the sliding scale line up with anything on the main scale. So thereabouts, and I can zoom in further out, sorry, but inch and 15/16 is close enough on this one. Last measurement to be taken is on the bearing is its thickness, like so. And let me just zoom in, not zoom in. There, so you can see what I'm doing. There, this is the last measurement. So I usually clamp the jaws tight here, so I have a solid contact surface and an accurate measurement here. Just carefully remove it, put it down there, and let's see what we've got here. Just gonna get rid of that one, and let's see what we have here. There, that's a great start. Okay. Standard procedure, the 0 on the sliding scale, you have to take a look at how many whole inches has it passed. There's 0 here, there's the first inch there, that's 1 inch there. It hasn't passed it, so I'm not writing down any numbers, any whole numbers. I'm going to write fractions from now. I'll just go a little bit this way so you can have it in the picture. The 16th and the 8th, the length of these lines are just slightly different, and it's kind of confusing for my eyes. I'm just going to go with the 0. So I don't know where half an inch is. It's a little bit hard to read. So I'm just going to count the 16th one at a time. 1/16, 2/16, 3, 4, 5, 6, 7, 8, 9/16, 10/16. I'm just going to write 10/16. Even though it's 5/8 of an inch, don't worry about it. I like working with 16th because I know that 1/16 is 8/128, and I need 16th to convert easily to 128. So 10/16, and I'm gonna need a measurement from the sliding scale. I gotta see which one of the hairlines meet up with any of the hairlines on the main scale. So which one of the hairlines on the sliding scale meet up with anything here. The 0 doesn't. That was pretty close. That's off. That's off. Those are all off. That was a pretty good candidate. That's 1/128. That hairline represents 1/128. So I have 10/16 plus 1/128. Now I need to add the fractions. But before I do, 10/16 is how many 128? Because they gotta have the same denominator. Alright. It's gonna be, I'm just gonna make it bigger. And maybe write it here. Just 10/16 plus 1/128. So it's the same as 10 times 8. That's a multiplication, okay? 10 times 8, 128 plus 1/128. Why 10 times 8? Because 8 128 make 1/16, then we have 10 of those, so 10 pieces of 8 128 is what we're talking about. So that's obvious that that's going to be 80. 80 128 plus 128 is 81 128 of an inch. End of story. So that's going to be the thickness of the bearing. We have 3 measurements taken, and we did an outside diameter, an inside diameter, and the thickness. Now with these 3 measurements, we can go and look it up in the bearing catalog and order the correct one for the elevator. Okay, that's how you read a vernier caliper in inches and fractions of an inch down to an accuracy of 128th of an inch. Keep practicing it.